As we saw in Unit 3, sometimes there are no answers to our systems of equations. In other words, there are no real solutions, but there are imaginary solutions. So once again, we should be familiar with graphing a line, a parabola, and a circle. So we should see here by quickly looking at these that this is two lines crossing. And two lines can cross, be parallel, or be on top of each other. We look here and we should know that this is a parabola, and we should know that the parabola opens up because it's positive and the x is getting squared, and that this is a line, and it also is a positive slope, so it's going up in the positive direction, and that here we have two circles. We know they're two circles because both the x and y are squared, and we should be rapidly discerning that the center on both circles is 0, 0, while the radius here is 1, and the radius to the other one is 4. So in essence, we have a circle inside a circle, so they don't cross at all. So just moving on with examples, the first question is asking, are there any real number solutions to this? Well, I always encourage you to go to Desmos first and get yourself a picture of it. We should know that it is a line, y equals 4. There's the line, y equals 4. Whoops, didn't really go through 4, but you got my idea. And then we have a circle whose center is 0, 0, and has a radius of the square root of 2. Well, the square root of 2 is approximately 1.4. So that means I'm going to be at 0, 0, and I'm going to go up 1 and 0.4. So from my picture, it doesn't look like it would cross. Double checking myself on Desmos, let's see, I'm going to put right here, y equals 4. Down here, I'm going to put x squared plus y squared equals 2. And when we look at my picture, we clearly see, let me put it on projector mode so you can see it, we clearly see that they do not cross. That's great, but on our regions, we're not going to have Desmos. We're going to have to show it algebraically. So that means I'm going to have to do some solving here. So I'm going to use substitution. I'm going to take the x squared plus, and then every time I see a y, I'm going to replace it with the number 4. 4 squared equals 2. Right now, our brain should be going, well, this is impossible because something squared is positive, and if I add that on to the number 16, I'm never going to get the number 2. But just to keep going, we get negative 14. And then we would know that x would have to be the plus or minus square root of negative 14. And this indicates an imaginary answer. Thus, the two graphs don't intersect. And that would be a full and complete reason and something we would look for on the regions. Does the line y equal intersect the parabola? Well, boy, this one is something you should jump up and down and celebrate because they told you one is a line and they told you the other one is a parabola. If so, how many times and where? Draw the graphs on the same set of axes. Oh, so they want me to graph this. So I'm going to graph it by hand. Even though we know Desmos is right around the corner, we need to show a graph ourselves. All right, so the line y equals x. Well, let's do that in green. So y equals x means I have starting at the y-intercept of 0 and then going up 1 over 1, up 1 over 1. Well, that's pretty easy. All right, let's connect that with a straight line. And we're, of course, going to label that. And now my parabola. So my parabola goes through 0, 0, and then 1, 1, 2, -4, and then negative, whoops, got to move that one over. And let's see, I can put a 3 in, so 3 squared is 9, which is going to make that negative. Negative 3 squared is positive, and then a negative out front. And then if I connect my dots, la la la, we're looking at 2 places where it intersects. It intersects, as we saw, at 0, 0, -1, -1. So if so, how many times? We'd have to say that it crosses twice. And where? We clearly stated where. And I'm going to check myself. So y equals x. I'm going to put in 0 equals 0. We get a check. Negative, whoops. -1 equal -1. Yes, we got a check. And y equals negative x squared. Well, I'm going to put 0 in. And that checks. And then I'm going to put -1 equals -1 squared. Yep, -1 squared is 1. And then negate it. So I'm good. Does the line y equal 5 intersect the parabola y equals 4 minus x squared? Well, again, I want to get a little thinking going on in my head. We could always go to Desmos, but y equals negative x squared plus 4. I rewrote it so I can see my x squared out front, and my brain should be thinking, that's my brain, and it's thinking, negative leading coefficient means I'm going to have a parabola that opens down. And then the plus 4, that's the y-intercept. So it's got a highest y-intercept of plus 4, but I got a line going through y equals 5. So right now my brain should be saying they don't intersect. And if we were to draw those graphs on the same set of axes again, y equals 5 is a line that goes through 5. Change that up. There we go, label it y equals 5. And then again, we've got the y equals negative x squared plus 4. So that means I go up 1, 2, 3, 4, because if I put 0 in, 0 plus 4 is 4. Now if I put 1 in, 1 squared is 1. -1 plus 4 is 3. And then I have its mirror image over here. If I put 2 in, well, if I put 2 in, I'm getting some roots right there. And that's really all I need. Because if I connect the dots, I clearly show that these two do not intersect. Now let's see, did I answer the regions question? Does the line y equals 5 intersect the parabola? Why or why not? Draw the graphs on the same set of axes. Well, if they're going to ask me to describe, then I would have to say something to the effect of this. The maximum, yep, let's use some words we learned, of the parabola is 0, 4, and that can't intersect the line y equals 5. There. Simple as that. We explained. All right, so it's been pretty easy. Let's just review a little bit. Solve the following system of equations, or show that it does not have a real solution. Now, or show that it does not have a real solution. Support your answer analytically and graphically. Okay, I put this one on here on purpose. Here's lovely Cuomo, Engage New York, Bill Gates, go for it, Common Core, making a conflicted statement. Solve the following systems of equations or show that it does not have a real solution. Here they're giving me an or. I can do one or the other. Support your answer analytically and graphically. Well, guess what, people? One time it says I can solve or graph it, and then now it asks me to graph it and solve it. So let's do both to be on the safe side. I'm going to use substitution. Every time I see a y, I'm going to replace it with x squared minus 4. X squared minus 4 equals negative x plus 5. X squared minus 4 equals negative x minus 5 as I distribute the negative. Now I see an x squared, and my brain knows every time I see an x squared, that means I have to factor. So I'm going to set equal to 0 and get all my variables and my constants on one side. So I'll move the negative x over, I'll move the negative 5 over. That doesn't look like it can factor. I can't find anything that multiplies to 1, but adds up to 1. So at this point, I'm going to come over and I'm going to do a little graphing. I have to finish solving this analytically, but I want to give myself a view. Does this cross and I'm just going to have it crossing in ugly places, or does it not cross? So let's not fight our brains. Let's just let a graph do the work. So x squared minus 4, it's a parabola that opens up, and it's easy to see that its vertex is 0, negative 4. So I'm going to come over here at 0, negative 4. Let's put 1 in. 1 squared minus 4 is negative 3. So it's got a mirror on the other side. Put 2 in. 2 squared is 4. 4 minus 4 is 0. So there are my roots. I'm just going to kind of go, let's see, because I know, let's see, I'm going to put 3 in. 3 squared is 9. 9 minus 4 is 5. And then there is my mirror image. And voila. There is my parabola. Now I'm going to take my graph here, and I know this is the graph of the equation y equals negative x minus 5, and I'm going to add this to my graph. So I'm starting at negative 5, and I'm going down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Well, it doesn't look like they cross. Even though I used a nice thick purple line, pink line there, it doesn't look like they're crossing. But I'm going to finish completing the square here just to make sure. So x squared plus x equals negative 1. I'm going to take half, there's my b value of 1. I'm going to take half of it, and then I'm going to square it, and I get 1/4. So I get x squared plus x plus 1/4 equals, well, -1 plus 1/4 is -3/4. I see. They don't cross, because if I were to rewrite this, I get x plus 1/2 squared equals -3/4, and that's right. I'm going to end up taking the square root over here and solving for x. I get x equals -1/2 plus or minus the square root of -3/4. And right there, support your answer analytically and graphically. This is not a real number, so therefore there are no real solutions.